Okay, today we're going to talk solar panels, and what the purpose of we're building these solar panels for is that we're going to have our wood shop solar powered. Now this is what the attempt is. I've already made 6-7 solar panels, anywhere from 150 to 250 watts each, but I'm going to build a few more, and I'll let you see how I did it and what I'm going to be doing with them. Now, not only am I going to run the shop with it, but I'm also going to make a solar powered kiln. Now, most solar powered kilns are done by the sun, hitting it, heating it up. I'm actually going to run a DC heater, and just see what we can do with that is what we're trying to make. So we're going to go through some of this and show you what we're using. These are the solar cells. I don't know if you can see them very well. These are polycrystaline. Okay, there's the front and there's the back. And these are just like a battery, I guess you could say. They got a negative, which would be the front side, and the positive, I believe, is the back side. Now, what we're going to do today, or this film here, is showing you how to tab these up and to get the voltage and wattage you want. This particular cell right here is 1.8 watts. Okay, I forget now the voltage and the amps it puts out, but we'll get to that later. So when you look at this, 1.8 watts don't sound like a whole lot, since how a small heater will take 600 watts, you know, so it takes quite a few panels to do something like that. But what we're going to be doing is charging the battery bank and then use it, because we don't use the shop. I'm not in there running all the equipment every day, so just see if we can have some fun and what we can do with this, and go over some of the do's and don'ts that I've learned, and talking about how brittle they are. Let's get into some of that. This is a broken one. Now, if you want to see how brittle they are, that's how easy it breaks. So, just snapping apart. See? So you want to handle these pretty carefully, but once you get started handling them, you'll realize that they're really pretty good, pretty easy to handle without busting, you would think. So what we're going to do is we're going to tab. Now I've got most of them already tabbed right here. This is one already tabbed up. Okay, and what we're going to use, this is tabbing wire right here, and it's soldered onto the front. Now we'll get into soldering together in strings here in a minute, but this is what we're going to do right now. And to do that, you need a flux pin. Okay, liquid flux. You just pump it in. I can put a little piece of tape right here. There we go. Get some flux put out. Just take and draw along that little white line right there. This is where your tabbing wire is going to go. Okay. Now, I don't know if you can see that. You just tab up these lines right here, and then we'll get down and we'll solder the tabbing wire to it. So let me set the camera to zoom it in a little bit for you so you can actually see me do it. Okay, hold on. Okay, we're going to tab these up. Now the first one, like I said, we're going to tab the front here and here, and take our flux pin. We just dab it here, get it wet. See how I use a piece of tape on there so I can peel it back up. Don't get a lot going on it because it makes a mess on the cells. Just run it down that whole length of the white line you'll see right there. Now you don't have to push real hard. And what I've done here, these have already been put flux on. You can flux a bunch at a time and then go back to solder, so you don't have to do it all at one time, or alternate. It's a lot quicker to do them all and then go back to solder. What I'm going to do is grab my tabbing wire, what you see here. Okay, now if you notice, it has a little bit of a bow to it. Okay, I like doing that and having it face down. Now you line this up to the end of the panel. Put one finger on the cell, one finger on the tabbing wire. Grab your soldering gun. About any soldering gun is going to work. It's just the tip. You want a flat tip. Like, I don't know if you can really see that. And you'll need a file, because now as you start soldering, this here will get all gunked up and you're going to have to file it down a couple times. Anyway, after you get it all lined up where you want it, start right here, and you start, you see the solder melting and running up. And right where I have my finger, I'm going to go ahead and touch that up. We'll grab another one, kind of straighten it out. You want this kind of smooth, because now we're going to encapsulate this with EV film, and any rough edges will take a chance of poking a hole or creating a hole in your encapsulant. Okay, now see how I got that down? Start right there, start running her down. Okay, now that right there, as you can see, tab good and hard, solid, ain't coming off. Now I'm going to go ahead and take a break here and tab the rest of these up. If you look over here, I have my ones that I've already tabbed up. I've got them in groups because each one of these is going to be a string. Okay, there's 18 in here be a string, 18 in there be a string. So in this panel it's going to have 4 strings with 18 cells on it. Okay, and I'm going to show you how we're going to tab up our strings to get the wattage and the voltage we want. Because, like I said, these little cells here is only 0.5 voltage, and I forgot the amps, but it comes up to 1.8 watts. But in order to charge a battery, okay, it takes at least a cell panel of 18 volts to charge a 12 volt battery. And the reason I say that, it's 18 volts when you just test it, but when it goes under a load, it's no longer 18 volts. Okay, so it'll drop it down to like maybe the 14 and 13 volt range, and that's, you know, still needed to charge a battery. So that's why you want these at least 18 volts, and that's for a 12 volt system. Of course, if you're going to go with a 24 volt system, you can have, you know, you take it about 30 volts when you test it, 34 volts, and that'll charge a 24 volt system. But just depends on how you're going to need it. But for what we're going to do here, we're doing it for a 12 volt system, and so we're going to tab these up in order for this panel to put out 18 volts, or somewhere in the neighborhood. 18 to 20 volts is great. And so let me finish this up and we'll come back to you. And okay, we've been tabbing our strings together, just showing you a little bit here what this is. Right now we've got 2 strings full, 19 in each string, and then we've got 2 more to do. I've got this one here started. Thought I'd show you real quick, tabbing the back loop, or tabbing up the back. So what you do is just go through here and put your flux on the little dots, or tabs. They got little white squares on the back that your tabbing wire will go to. Now you can solder the whole thing straight down, or you can just do the spots. Makes no difference. I mean, you're not talking a lot of high voltage anyway, so I don't think it really matters a great deal. I didn't see anything that gave me that indication. Okay, let me pick up my lid here. And then what we'll do is, in order to keep these straight, I use the edge of the glass. I got me a lip on it, and I'll put my cells up against it, and I'll bring the next cells to be tabbed, and I'll bring it and line it up. See, then I'll just take, and after I get my desired spacing that I wanted, then I just go through and solder the tab. After you get that first one, then you gotta do is just hold your finger and run it up. It takes it right on. Now, sometimes the tabbing wire didn't get really straight on the front side. And when that happens, you just gotta push it over a little bit and run her straight up. She's tabbed. Now you notice we're taking from the front side, and so I'll show you here. So this wire here is from the front, okay, which will be your negative, and we're tabbing it to the back, which is a positive. Every time you do that, you increase your voltage. So we'll discuss all that there at the end. Right now, I'm just trying to get this together, and then we'll test it before we encapsulate it. Now I'm going to tab these right here on. Okay, let me just show you what we have as far as these strings here. Okay, right now you'll see where we got, this is our panel. This is actually the size of the panel that we're looking at. So what we're doing here is, if zoom in on this a little bit, you can see them tabbing wires sticking up right there. These two right here. Put that another way. Okay, now this, if you'll notice, is coming from the front side. Okay, so these two will bend over, tab over, and lock into the back side of this. That way the string continues and build up the voltage. So I've got it kind of close. I may not be able to use this last cell, but we'll see. It's getting real close to the end right here. But anyway, we'll do both strings tied together like that, and then we'll do two strings just the opposite on the other side. Well, they'll do the same thing, and then we'll tie the negative and positive of those two strings, or positive to positive on those two strings, and negative to negative, and that will increase our amperage. So we're still going to get 18, 19 volts, but now by doing that, because these two strands here will give you the let's see, 19.5 volts, is it, or something like that, and those two strings over there will give you the 19.5. And that's by using this extra one. I can take this one out and still get my 18, but I think I'm going to keep it if I can. But when you add these two together, you're still going to get the same voltage by adding the positive to positive, negative to negative on these two strings. But you get more amperage that way. So that's what we've got right now. I'm going to go ahead and finish this up, and then we'll start putting it and encapsulating. Now the encapsulant that we're going to use is an EB. It's like a big plastic sheet. We'll lay a layer down, have the cells on top, and then we'll put another layer over top of it. We'll hook a vacuum to it and seal the edges, and then vacuum the air out, and then we'll take a heat gun and we'll melt them together, and it'll sandwich these two in to where it stays completely dry, so it protects everything from the weather. I did one, I like it better. They've got another product you can use and pour it in and liquid. It may work, I don't know, I haven't used it, but I do like the EB. So I'm going to go ahead and get this done, and then in another day I'll show you how to do the vacuum. Okay, so if I've left something out, send me an email or post something, and I'll correct it or whatever, but I think that's pretty much got it. Honestly though, it's cheaper. Well, it's cheaper to build your own panel, but it's easier just to go out and buy the thing. A 100-watt panel is about maybe 120, 150 bucks. I think that's with free shipping on eBay or something like that. So when you really look at the price versus how long as it takes you to do this, it's probably cheaper for you to go out and just buy the crazy things. But by doing this, it, you know, better than school. I'm telling you, you'll learn more by putting your own panels together than you will studying. You can study all day and still not understand what you got. Okay, thanks for watching. Come back or keep an eye out for my next video on encapsulating it, and then we'll do another video on mounting it and showing you how we're going to set up the solar kiln and operate the shop with it and what it's going to take. Maybe I can, maybe I can't, but we'll just see how well we do with it. Okay? Thank you for watching. Don't forget to subscribe.